Hi children, hello, welcome to your home school this year, class 10 mathematics NCERT or CBSE board. We are in our chapter 8, the real numbers, and this is your exercise 8.2, third main. Let's start here. Find the LCM and HCF of the following integers by applying the prime factorization method. In this main, we have 3 sub-questions. Let's start with the first one. What we need to calculate by using prime factorization? We need to find the HCF and LCM. What is HCF? Highest common factor. LCM, least common multiple. Let's solve first problem. 12, 15 and 21. By using prime factors we need to do. So let's draw the prime factor tree here. 12. What are the factors for 12? 2, 6, 12. 6 is not a prime number. So what I need to do? Again I need to split. 2 3s are. So 2 6 are 12 and again 6 I can factorize. 2 3s are 6. Finally I can write 12 equal to 2 into 2 into 3. Similarly, do 15 factor tree. 3 5s are 15. That's all. So 15 is equal to 3 into 5. Next one, 21. 3 7s are 21. 3 7s are 21. Okay. So now in these 3, which prime factor is common? Which is common factor, children? Here you have 3. Here you have 3. Here also you have 3. Therefore, 3 is common prime factor in all the given 3 numbers. Therefore, what you can say? HCF of 12, 15 and 21 is equal to 3. They have asked us LCM also. LCM, least common multiple. So this 3, write one time and then write 2 into 2 and then 5, 7. Okay, now start multiplying here. How can you multiply? 3 2s are 6. 6 into 5 2s are 10. 10 6 how much? 60. 67 are 420. Observe here once again, children. 3 2s are 6. 2 5s are 10. 10 6 are 60. 67 are, you multiply, write 0 and multiply. 7 6 are 42. So your final answer is 420. You can write it as LCM of 12, 15, 21 is equal to 420. Similarly, do the next problem. Second one, 17. Split 17. No, I cannot split. 17 is first of all a prime number. So I can write it as 17 ones. 17 equal to 17 into 1. 23. 23 is also a prime number. I may write it as 23 ones are 23. And again 29. 29 ones are 29 ones are. Therefore, what is your HCF, children? 17, 23, 29. What is your HCF? What is a common factor? Prime factor, it is 1. So, you have a common factor, that is 1. H is equal to how much? H is nothing but HCF of 17, 23, 29 is 1. Now, we need to calculate LCM. LCM of 17, 23, 29 is 1 common factor, right? Into multiply remaining numbers 17 into 23 into 29. If you multiply, you are going to get this answer as 11,339. This is your LCM. See the third problem. 8, 9, 25. Split prime factors. 2 4s are 8. Again, this 4 can be split as 2 into 2. And now 9. 3 3s are 25. 5 5s are 25. Rewrite this. 8 equal to 2 into 2 into 2. And 9 equal to 3 into 3. 25 equal to 5 into 5. See, observe here children, is there any common number? No, there is no common prime factor here. So if nothing there, what you need to write? You can write it as HCF of 8, 9, 25 is equal to 1. Nothing there, 1 you can write. Next, LCM of 8, 9, 25 is equal to, multiply all these children. That means 2 into 2 into 2 into 3 into 3 into 5 into 5. Okay. So, how can you multiply this easily? 5 into 2, 10. 5 into 2, 10. 10 tens are 100. 3 3s are 9. 9 2s are 18. 18 into 100? 1800. So, LCM of 8, 9, 25 is how much children? 1800 is your answer. HCF is 1, LCM is 1800. This is the way we need to split the prime factors and then take the common numbers as HCF. Product of the prime factors, we are going to get the LCM. Let's see the fourth problem. Given that HCF of 306, 657 is equal to 9. Find LCM of these two numbers. So, let's start our solution. How can we find this, children? They have given that HCF of two numbers is 9. And we know the two numbers. Find the LCM is your question. Let us start here. We know that, what do we know children? We know HCF into LCM is equal to product of numbers. Product of numbers means what? H into L is equal to A into B. Now what is HCF of these two numbers? H is 9. We don't know L. L means LCM. What are the two numbers? Take the numbers here. 306 into 657. Now this multiple 9 send other side. It will be divided. 306 into 657 by 9. Now let's cancel. 9 3s are 27. 3 will be left. 9 4s are 36. Now multiply these two. 657 into 34. Do the calculation part here. 4 7s are 28. 4 5s are 20. 22. 4 6 are 24. Plus 2 26. 7 3s are 21. 5 3s are 15 plus 2 17. 6 3s are 18 plus 1 19. 8 3 13 12 2. What's your answer here children? LCM is 22,338. Finally, your answer. LCM of 306, 657 is equal to 22,338 is your answer. See your children, observe carefully. We know the formula. H into L is equal to A into B. Any one term is missed, change the formula and then you can find the missing term. Let's see the fifth problem. Check whether 6 power n can end with the digit 0 for any natural number n. What do you mean by this children? 6 power n. N might be any natural number. Suppose if I take natural numbers, I am saying 6 power 1. What is 6 power 1? 6. Similarly, 6 power 2 means 6 6 36. Next natural number is 3. 6 cube means 6 6 36, 36 6 216. Similarly, 6 power 4 is equal to 1296. 6 power 5 is equal to 7776. Like this, if you go on doing, do you get anywhere the 6 power n can end with the digit 0? Means, is this digit is ending with 0? Is the question. No, it's not ending with 0 here. We can say directly no, but it is a theoretical problem. We need to prove it. How can we prove this, children? See here, this is only the theoretical part there. So, I have already written, but the missing gaps I have left. You need to answer that. If the number 6 power n for any natural number n ends with 0, if it is ending with 0, what we can say, children? If any number ending with 0, it will be divisible by 5 or 10. Right? If any number ending with 0, it must be divisible by 5. Then it would be divisible by what? 5. That is, the prime factorization of 6 power n would contain the prime factor. It should contain a prime factor 5. If it is divisible by 5, then this prime factor should contain 5. This is it possible or not possible? Let us solve this. 6 power n, split this. 2 3s are 6. 2 into 3 whole power n. You can write it as 2 power n into 3 power n. Can you see any prime factor 5 here? No, it's not possible. I can write it as this is not possible because 6 power n is equal to 2 into 3 we can write. I cannot split this 6 as 5 into or a 5 multiple. There is no 5 in this. Right? Therefore, it is not possible. So, the only primes is the factorization of 6 power n are, what are the only primes? 2 and 3. And the uniqueness of the fundamental theorem of arithmetic guaranteed that there are no other primes in the factorization of 6 power n. 6 power n, there are no other primes other than 2 and 3. So, there is no natural number n for which 6 power n ends with the digit 0. So, will it end with 0? No, it never ends with 0. How to check, children, whether it is ending with 0 or not? You should see the prime factors. If you have 5, then I can say that then it is divisible by 5 and it is having a factor 5. Therefore, it can end with 0. Right? So, same type of question they may change and ask. They may ask you 4 power n or 8 power n, 7 power n, like this. They may change the question. But the technique is same. If it is divisible by 5 and if it is having a prime factor 5, then it is a number which is ending with 0. This natural number which ends with 0. Let's see the sixth problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. They are saying that these are composite numbers. Why? Let us see. 7 into 11 into 13 plus 13. Let me take. So, in these two, 13 is common. Remaining things multiply here. 7 11s are 7 into 11 into 13 plus 13. Observe the symbol here carefully. Into plus, children. So, this full complete one set you consider. Okay, in these two what is common? 13 is common. Other than 13 remaining terms multiply. 7 11s are 77 into 13 plus 13. Now take out 13 common. 77 plus 1. 13 into 78. 78 Further, I'll split this. How can I split this 78? Look here, let me go with the prime factorization. 2 3s are 6, 2 9s are 18. Then again 3 1s are 3 3s are. I just split with 2 into 3 into 13. Finally, I write this as 2 into 3 into 13 square. Why I am saying it is a composite number? Because it is a multiple of multiple of two prime numbers, it becomes a composite number. Do you know that? Therefore, it is a multiple of more than two prime factors. Therefore, it is a composite. It is a composite number. Okay, one of the sub question is completed. What did we do, children? In these two, what is common? We have taken first. Remaining terms multiplied. Take out 13 common. Add. I didn't get here prime number. It is a composite number. So again split in the form of primes. Now if you write this, you can see more than two prime numbers are multiplied here. Therefore, it becomes a composite number. Right? Let's move to the next one. Rewrite the question again. 7, 6, 5, 4, 3, 2, 1 all multiplied plus 5. You can see plus symbol here carefully. Now in these two terms, what is common? 5 is common. So other than 5 multiply, children. 7 6 42 into 5 into this all you multiply. 4 3s are 12, 12 2s are 24, 24 1s are 24 plus 5. Now take out 5 common. Okay. Multiply 42 into 24. What you are going to get? 1008 plus 1. If you take out 5 common, 1 will be left now. Then that will be 5 into 1009. So these two are the prime factors. Therefore, it is a composite. Therefore, it is a composite number. Why we are calling, children? If we multiply two prime numbers, we are going to get a composite numbers. Let's see the last problem of this exercise, children. That is 7th problem. There is a circular path around a sports field. Let us imagine. You can see the circular path around the sports field, children. Imagine it is a circular path. Sonia takes 18 minutes to drive one round of the field. So let's mark here Sonia and Ravi. So starting point I am assuming here. Right? They are driving. Sonia takes to drive the circular path. She takes 18 minutes. While Ravi takes 12 minutes for the same circular path. Suppose they both start at the same point at the same time and go in the same direction. Same direction they are moving in a circular path. After how many minutes will they meet again at the starting point? So understand the question carefully, children. There are two persons. They are going to drive in a circular path. Who are the two persons? Sonia and Ravi. Sonia takes to take one round. She takes 18 minutes. Whereas Ravi to go a drive of one round 12 minutes. Just they are moving in a circular path. They did not stop here. But after how many minutes these two are going to meet at the same point? How can we find this, children? Understand the question carefully. If we are able to find the least common multiple of these two, we are going to get the answer. So let's start here. Our solution. Given. What is given? Given Sonia Sonia takes 18 minutes to drive one round of the field, and whereas Ravi takes 12 minutes to drive one round of the circular path or a field. You can write anything, right? How can we get the answer? What is the answer? After how many minutes will they meet again at the starting point? We need to find the least common multiple. Least common multiple of these prime factors. Least common multiple of these two numbers. What is that, children? 18 and 12. Let's find here 18. 2 into 3 into 3. 2 3s are 6, 6 3s are 18. Similarly, write 12, children. 2 into 3. Yes? Now, let's round it common first. Write these one time. Now, LCM of 18, 12 is, first write the common terms 2 into 3 and write the remaining terms. Multiply this. 2 2s are 4, 3 3s are 9. 9 4s are, it will be 36. Finally, what you can write, children? Therefore, let me write the statement here. Therefore, after 36 minutes, Sonia and Ravi meet again at the starting point. Similarly, children, they may ask you any other question. So, 2 people here, there, 3 people, 4 people like this. If they ask, you just find the least common multiple of all the numbers. That means after that many minutes, the 4 people are going to meet at the starting point. With this, we are going to end our session, children. This is the end of your 8.2 exercise. In our next session, we are going to continue with the next exercise. Until that, keep watching. Thank you all.